Hi, just give me one moment while I have our presentation ready to go. Can you all see the slides? Can you all hear me okay?
Yes.
Okay. Thank you all for coming. Hello, everyone. Thank you for choosing to spend the next 75 minutes with us at this virtual workshop entitled Python Basics for Librarians and Archivists. Today is the last installment of the 4-part workshop series on this topic, which has taken place April 18th, 20th, 22nd, and today the 25th. My name is Nashieli Marcano. I am archivist and digital collections librarian at Furman University and a co-convener of the Digital Scholarship Section's Digital Collections discussion group. I will help moderate the Q&A session and the chat for today's session. This series of workshops was developed by the DSS Digital Collections Discussion Group, the Digital Humanities Discussion Group, and the Professional Development Committee in collaboration with both the Equity, Diversity, and Inclusion Committee and the Outreach Committee. Thank you to all our presenters, ACRL staff, and DSS committee members for their coordinated effort. So, in the spirit of encouraging equity, diversity, and inclusion in the DSS community and beyond, I will read a brief statement. Please take a moment and review the guidelines on this slide. We, the DSS community, agreed to frame interactions in DSS activities with these guidelines in mind. We recognize that whenever we engage as a community, we will all make mistakes that may unintentionally harm individuals or groups, but we agreed to take responsibility for the results of our words and actions. We expect that all DSS meetings will begin with a brief review of these agreements so they may become standard for activities in the section. Okay, next, I will introduce our panelists. We have Nathan Kelber. He is the Consulate Education Manager for JSTOR Labs. He leads community education for the text analysis platform Consulate and is the director of the Text Analysis Pedagogy Institute, a national institute funded by the National Endowment for the Humanities. We also have Amy Kirchhoff. Amy enjoys her long career at JSTOR, Portico, and Ithaca. She's currently the business manager for Consulate, which offers a comprehensive and easily accessible program that helps you develop text analysis and data mining competencies, along with related skills through multiple modes of learning and hands-on participation and application. Please welcome Nathan and Amy, and I'm going to stop sharing the screen.
Thanks so much, Nashieli. You've been really crucial in organizing this, and I don't know that it would have all come together so neatly without your help. So I just want to thank you in front of everybody for being a really important part of putting this all together.
My pleasure.
And I want to thank my colleague Amy, as always, who is my co-pilot and co-teaches. She's seen me teach a lot of these lessons so many times. Thank you, Amy. She'll be monitoring the chat and bringing things to my attention in case I miss anything. I'm going to go ahead and jump in. Let me share screen here. And we're just going to go to consulate.org. This should be fairly familiar with folks by this point in time. Today is our final session. So we're going to go to consulate.org. You're going to go ahead and log in the upper right-hand corner here. It should say your dashboard. If it doesn't, then you'll need to click login and create an account at my JSTOR. All you need to create that account is an email address and a password. And I should say that the Consulate platform will stay open to everybody that wants to use it up until Wednesday. We basically opened it up, especially for this ACRL workshop series. If you're interested in continuing to use Consulate after the workshop series, then get in touch with us and we can talk to you about doing a trial on the platform and doing a trial at your institution, basically. So I'm going to go ahead and go to classes and tutorials. All of the lessons that we've been working on together are here under beginner lessons. We're going to do Python Basics 4 today. I should say there's also now a Python Basics 5. It's not, I want to add a little bit more material to it, so it's not listed here on this page, but you can get to it once you're in the lab environment, just by kind of going to File, Open, and getting to it that way. So once you've gotten to Python Basics 4, go ahead and click on Open in Consulate Lab, and that should get you started. And thank you to those of you that applied for the Text Analysis Pedagogy Institute. The number of applications was a 25% increase from last year. Last year we had 200 applicants. This year we had 250 applicants. And I suspect it'll take us a while to review those, but hopefully we want to get back to people in about a week here. So if you have applied to the Text Analysis Pedagogy Institute, sit tight for about a week before we're able to review your application and let you know if you've been admitted.
Nathan, we have a question. Are applications still being accepted?
They're not currently being accepted. They were accepted through last Friday. I think I have an email from you, Daria. I'll respond to you under separate cover. It's taking a little bit longer than usual to start up today. I'm not sure.
We have a question from a participant. Kill time, can you explain end from session 3 solutions? End in quotes, thanks.
Sure, let's take a look at that one. I'll show you as soon as my session starts up. Let me try reloading it. It may be just starting up another pod. If everybody starts at the same time, it's got to generate all the resources for all the participants.
Yeah, I'm in. So you hit it at a pod loading moment, I think, Nathan.
Okay. That's a good data point for us, Nancy. Thank you. I'll take note of that. One of the things I was talking to the developers today about was whether we can basically just get data on how much time it takes to launch each class and see if there are issues. It does seem to be going a little bit slow. This way. It says it's running. Oh, I guess it's already running. Okay. So we're gonna do Python Basics 4. And as you can see here, like I said before, there's a Python Basics 5 as well. This is Python Basics 5 is really focused on working with string data. So if you're interested, you can get to it by essentially when you're in a particular lesson, you can just go to File, Open, and it will expose kind of all the different notebooks that are available. Anything that ends in a .ipynb is a Jupyter notebook. And if you use GitHub, all of these lessons are also on GitHub at this address, which I will share with you now. And you can download notebooks from there as well. Okay, we had some questions about Python Basics 3, and I had one question about possibly a kernel timeout or something like that. If you notice that it becomes unresponsive, one thing you can try is go up to the kernel menu here and then go up to restart. And sometimes that will resolve an issue where the kernel has timed out because the connection is a little bit flaky, or the session has sat for like 45 minutes or something without any input. It will sometimes stop the session and kind of reclaim those resources for other folks to use. So let's take a look. There was a question about the coding challenge. Are we looking at the list coding challenge or the dictionary coding challenge?
Lists, Nathan, that seems to be what people are saying, list code.
Okay, let's take a look at this. So we started with a list, and in the first example with lists, we had a book list, and so this is just a list of strings. These are all medieval texts, and then there were a number of different solutions here. The first one is just using a little bit of flow control, and so we can do a for loop in working with a list. And one example of that, for example, here, this 1A solution, for the book in the book list is the variable here, print, and then here we have book, which will be the current variable that is being loaded. So it's essentially going to go through each time and load one of these strings in each time. So this is going to print the book name, and then it's going to affix to that book name a comma and a space. And then essentially just print them all out in a list like that. Now this isn't completely neat because for one thing, we end up with a comma at the end here. One thing I should say also about the solution is it requires this end equals empty string. And this end equals empty string is what keeps the print from printing a new line each time. So every time you use a print statement, it's going to create a new line. And if we don't have this end equals empty string, then our solution will look more like this. It'll be one line each. And so this end equals empty string allows us to put everything on a single line. So this is one way to do it, and this is using concatenation. This version right here is very similar, but instead of using a plus operator, it's using an F string for the solution. And so this allows us just to insert the book with a comma after it. For the second solution, we have something a little bit more sophisticated. This is going to look at the length of the book list, and then it's going to basically go through the book list, the number of times that is the length minus 1. And so this is going to essentially print out each of the items in the book list. And then finally, except for the last one, we're skipping the last one. That's what the -1 is helping us do here. And then finally, we have a separate print statement, which is just referring to the last item in the list. So we have a book list, and then we have an index of -1. That index of -1 is going to print this Le Morte d'Arthur finally without putting a comma. So each of these prints in our kind of flow control here is going to print with a comma. But if we don't want a comma at the end here, then we're not going to print that last item with our flow control. We're just going to print it on its own. And so this print is in a different code block. It's one left, so it's not actually inside of our flow control. And so that's actually what's happening here, is using I with in range at the same time. With solution 3 that we have here, we're doing a while loop with a count iterator. So here we have I equals 0. And then we're doing something sort of similar. We're taking the length of the book list and we're subtracting 1 from it. So we're not doing all of the items in our list. But then we're just printing, and then we're adding 1 to our count iterator each time. And that I variable could be anything we want to call it. But in this case, it's just I. And so then notice again, similar to the example above, the last item, the final book, is printed separately from the flow control in order to make sure that we don't end up with a comma at the end. And the last one, a method that I didn't show you, but I wanted to show you at least in the solutions, is this .join method, which is a string method that you can use. And actually it is shared in Python Basics 5, which we won't cover together, but I want you to know it exists because it exists basically for this purpose, to join together lists of strings. And so basically what this does is you can define what's going to go in between the strings here, and then you pass in a list here. I find the way that this is, the syntax, a little bit confusing in the way this is written, but essentially whatever I put inside here is going to be what is in between the items. So if I put like a vertical bar or something like that, that's what's going to be inside or in between each item that it prints out. And so here I've just put a comma with a space, and it will join together the items. Notice it also doesn't put a comma at the end. It's smart enough to figure out to only put whatever is in the string here. And so in a sense, this is kind of like just concatenation is really what's happening here. It's grabbing each item one by one, and then it's concatenating a space. So those are what, 5 possible solutions that you could do this. Some of them are a little bit more sophisticated than others. And I'm sure there are additional solutions that folks came up with. But there's definitely a lot of possibilities for accomplishing this in Python. Let's see. Nashiali has a question. For a dictionary key value pair, can the value be a list, or does it have to be a single string? You could have a dictionary where the key or the value, well, ideally, I guess the value would be it could be a list. And you could have a list where an item inside of the list is another list. And so you can mix and match these structures in such a way. So sometimes you'll see, I think maybe I had an example of that somewhere. Maybe not in this lesson. But yes, you can have, for example, you can have a key whose value is a list of items. And so then when you supply the key, it will return the list. That's certainly a possibility. It doesn't have to be a single string. It doesn't have to be a string at all. It could also return, let's say, an integer or float or other data types. It could return like a Boolean true false. So whatever data you want to put in there, it can return something a little bit more complex. But I'm trying to show just kind of the basic structure of what these things usually look like. That's a good question. And if you start getting into working with things like JSON, then you'll see more complicated structures in working with these dictionaries, rather than just a single string for a key and a single string for a value. Any other questions folks have before we jump into Python Basics 4? All right, let's jump into Python Basics 4. I'm going to go ahead and close this table of contents here on the left. For our final class today, we're going to talk about functions. We've used functions a little bit. We've used print and input, and we used range when we were doing some flow control and things like that. But we haven't talked too much about kind of what functions are and like the opportunities that exist in using Python with functions. So we're going to go into a little bit more detail. And so I have talked about the fact that you can usually identify functions because they have parentheses on the end of them. That's where we can pass something into them. And I mentioned that we were using methods before when we were looking at lists and dictionaries. And I mentioned that a method is a kind of function. It just uses an object as well as having a spot to pass in arguments. But let's talk about a little bit more detail what functions are. You can think of functions kind of like a convenient shorthand or like a mini program. And the idea here is that that you pass something into a function, the function does something for you, and then it returns something back to you. And sometimes people refer to this as a black box. And the idea here is that you shouldn't have to know everything about what the function is doing. You should just be able to kind of input something that has the correct form and then get something back out of it. So it's almost like if you envision like a conveyor belt, you're like, well, I have this variable and it's a list. And so if I put that variable through on the conveyor belt and it goes through the black box, it's going to come out the other side looking how I want it to look. And so the idea with this black boxing is that it allows us to make our code much more modular. And so like we don't have to write every single thing that our program is doing all the time. We can sometimes just rely on a function that has a piece of code in it that we use quite often. Now, there may be times that you want to see what's happening inside the black box, and that's possible as well. You just have to kind of look up the code for that particular function. But most of the time, we just kind of need to know what are the things that are getting passed in and what are the things that are coming out. And so Python has a number of functions like print and input and range and things like that that are included by default. But there are also like thousands and thousands of functions out there that other people have written. And so it's often a good idea before you start trying to write your own functions to check out whether somebody has already written something like it, because the odds are pretty good that the function has already been written. There are so many functions out there and they're in all different areas. And sometimes people ask me, well, if there are so many functions out there, why don't we just include them all? Why don't we just have them all in Python by default? And the problem with that, unfortunately, is that a lot of people would name their functions the same thing. And so you can imagine a situation where somebody would have a financial function that does a calculation related to banks. And so they call that the bank function. And then you can imagine somebody else has like a simulator for airplanes. And so they're simulating the air that flows over the wings when an airplane turns. And so they call that a bank function. And then you have somebody who's studying soil erosion and the way that waves move across the bank of a river or a lake. And so they have a bank function. And so the problem then would be you have 3 different possible bank functions and you wouldn't necessarily know which one was which. And you would have these kind of collisions between the names, right? So the idea is that if you want to work with a specific set of functions, you import the module associated with those functions. And usually they're in a particular area of expertise or specialization. So you import that module, and then you can use the functions that are associated with it. And you can import, say, one function at a time, or you can import like a whole bunch of functions and have access to all of them. And so the idea is that by default, Python comes with certain basic functions. And then if you want to do more advanced things, you import modules to get access to a greater variety of functions. And so I'll show you kind of what that looks like in code. We can go back to our first day where we imported the time module. Remember that? It seems so long ago now, but this first example in the code here is importing the time module, and it's just import time. Time is the name of the module. And then it's going to print waiting 5 seconds. We know what that does. We're familiar with that. And then here I call the sleep function from the time module. And so the syntax is just time.sleep. I pass in 5. And so that is going to print waiting 5 seconds. It's going to wait 5 seconds according to the time.sleep function. And then it's just going to print the word done. So a little flash of the past from where we started. Now you understand a little bit more about what's happening here. We're importing the time module, and then we're calling the sleep function within the time module. And that's essentially what is happening in this code cell. I think we're looking at the right screen. Am I sharing the wrong screen?
It looks okay to me, Nathan, but I'll talk to Heather and see if I can find out what she's looking at. We'll make sure.
Okay. Sorry if I'm sharing the wrong screen. Okay. Okay, so Catherine asks, if there are modules that are named the same thing, how does Python know where to import from? So the modules ideally should not be named the same thing. There is a kind of list, an official list of modules. And the idea is that you install things using an official installer. There's actually a few installers, but the most common is something called pip, P-I-P. And I'll show you a little bit about how you would install something that wasn't installed by default when we get to that point. Okay. Another way that we can do this is rather than importing the time module, the entire thing, we can import just the function that we want from the time module. And so in this example here, we can go from time import sleep. So this is basically saying from the time module, and I'm going to put these both on the screen at the same time so you can see why this is slightly different. Just import the sleep function. We just need this one function to work with our code. And so this also says print waiting 5 seconds. But look here, when I call this function, I just have to call sleep. I don't have to call time.sleep. And so that's the difference here is it's importing just that function. And so I can just call sleep and then pass in the 5. If you had like some kind of collision type issue where you felt like you might have 2 functions, then it would probably be better to do this way, because this way allows you to specify that we're pulling the sleep function from the time module. Whereas here, we're just calling the sleep function. But it may be that you just need one function, and so you just pull that one in rather than just importing the whole module. So time has multiple functions. It has all sorts of different functions in it. So in this case, we have to be a little bit more specific. Okay, so that shows you some of the opportunities that exist in importing things. And I'll talk at the end of this lesson about some of the modules that are out there and some of the opportunities that exist for doing work with Python and places you should look to kind of begin growing your Python skills. But before we do that, I want to talk a little bit about how you can create your own functions, because really all of the modules that you can create are just created by other people like you that have written code, and then all they did was package them up in such a way that they're easy to download. And so if you know how to write your own function, theoretically, you could easily create your own module. It's not really very difficult to do and make it available. And if the code is useful, other people may use it. Okay, so this is how we create a function. First of all, we need a function definition statement. And then to actually use the function, we have to call it. And the definition statement looks a little bit like a flow control example that we've already seen. So it starts with DEF for definition. Then it starts with a name that is whatever we want to call our function. we have our open and close parentheses, and then we have a colon, similar, like I said, to flow control. The next section here, we have these triple quotes. They can be triple single or triple double, but the idea here is it gives a description to what the function does. Ideally, it's going to describe what goes into the function and what comes out of the function. In case somebody sees the function, they're like, I don't know what this is, they can get that description back and it will give them a description of what the function is going to do. And then underneath the function description is the actual code that's going to get executed. And then that's just the definition. Once we have the definition in place, then to actually run the function, we have to call it just like any other function. And so we call it in the code. So just because we've defined the function doesn't mean that the function is going to run immediately. We have to call the function in order for it to run. So I've got an example here. I'm calling the complementer function. And so you can see my, this is called a doc string. And so my doc string here says it takes in a name string and then prints a complement with the name. And so that just explains to somebody who's never seen the complementer function before what this thing does. And you can see in my function, all it does is it prints, you are looking great today. And then it puts the username afterwards. And so here I've got a little bit of code here to ask what is your name, and then it's going to run the complementer function, and then it's going to say who is your friend, and we're going to put that in username, and then it's going to run the complementer function again. And so each time it's going to create this complement. So I'm going to say, what is your name, Nathan, and then you were looking great today, Nathan. Thank you, complementer function. You're such a helpful robot. And then who's my friend? My friend is Amy. And it says you are looking great today, Amy. And so that's essentially what I define the function here. And then I called the function in these two places here. And so I've already talked a little bit about the docstring notation here. But let's talk about kind of how would we actually even get access to this docstring? How do we see that? And so one thing we can do is we use the help function, and then we just put in the function that we're interested in. So I put in help, and then inside I pass in the argument complementer function. One mistake people often make here is they put in complementer function like that with the parentheses there. The parentheses should not be there when you're using the help function. And so when I do help and I pass in the complementer function, I get the doc string that I've associated with it. So it says takes in a name string, prints a complement with the name. Doc in this case would be DOC as in documentation. Yep. And so I'd like you to try that in the next code cell. We've already imported the sleep function. See if you can use the help function with the sleep function to see the doc string for the sleep function. And you can use this with any function. And that's one reason I want to show it to you, because you will run across functions that you haven't used before and you're like, well, tell me a little bit more about what this does and what I can put in and what can come out. So in this case, we would do help, and then we could do sleep like that, or we could probably also do time.sleep. Oh, did I not run this up here? I didn't actually import the sleep function. Didn't run that code cell. All right, so there I did help sleep, and it says delay execution for a given number of seconds. The argument may be a floating point number for sub-second precision. And that's useful. I didn't know that before I did the help function on sleep before, and I was like, oh, I guess I can use floats. So you could pause not just for 5 seconds, but for 5.2 seconds if you need to be really precise. You could do that. And so that is the help function, which is helpful. Another one I'd like you to know about is something called type. Maybe let's try this. We do something like name, and I create the name, and then so I have a variable there, and I want to know what's stored inside of name. There's something called type, and I can pass in the name variable here, and it will tell me that this is a string type, str. And so another thing I could do here is I could turn this into an integer, and then I could do pass it in again, and you can see that this now says integer. And so this is not necessarily related to functions per se, but along with the help, this type function is a useful thing when you're trying to write Python code, or you're trying to see what's inside of a variable and figure out, maybe you have an issue where you're concatenating strings and integers, and you're like, what is this variable? Is it a string or is it an integer? You could use this type function and figure out what type of variable is inside of there. The great thing about writing these functions and using these functions is that you don't have to retype your code over and over again. And so anytime you find yourself reusing a piece of code or I'd say once you've used it 3 times, it should definitely be put inside of a function so that you don't have to repeat your code over and over again. And the nice thing about this is that if you need to make a change to what the function does, you only need to change it in the definition and it will change. So let's try that here. Change the complimenter function to give users a different compliment. So here it says, you are looking great today. Change our complimenter function and try it out with a different compliment that you put in. Yes, the type function will tell you if it's looking at a list or a dictionary or some other type of object. There are additional data types that we just don't have time to cover. And so there are other objects out there, other types of data out there, but lists and dictionaries, I think, are the most important to learn. So if we're going to change our complement, we would change this F string here to be something else. So it's sort of like a complement, I guess. I can change that F string to something else. And then each time these complementer functions are called, it will essentially print out our new string. And so the nice thing here is that we only had to change the definition in one spot and it changed in 2 places, which is not a huge deal in our case, but keep in mind that your program could be hundreds of lines long and you may have called that function a dozen times. And so if you had the same code in 12 different spots, you'd have to go through the whole code base and find it in each spot and change it in each spot, doing a control F for something like a find and replace. And if it's a really big program and you're working on a team, it could create a lot of problems. So having it written in one spot is really useful. It's also just helpful from a bug testing perspective to have like one single source of truth, like this is what the function does and this is what's happening. And then you can just look at that one spot rather than having to check to make sure all 12 of the places where that code is at are all identical and there's not like a stray comma or something somewhere. And so one of the things that programmers will do is something called deduplication, where they're essentially going through their code and they're looking for duplicate code and trying to remove duplicate code. And so that if there's code that's repeated in a bunch of different places, it's put inside a function, and then it is that function is then just called in each spot, rather than having repeated code. It saves yourself from creating errors and problems, and it makes your code easier to maintain. Yep, that's exactly right, Kara.
Hey, Nathan, Jane Annette's having a problem with her code not calling help.
Okay. It should look exactly like this. Are you seeing an asterisk here, or is there a number here? No problem. If you see an asterisk, that means the code is still running. What you could try doing is clicking on the cell that still has an asterisk in it, and then pressing the I key for interrupt twice, or possibly going up to kernel interrupt. You can also do, and then try running the cell again. You could also go up to kernel and go to restart and see if that resolves the issue. Or restart and clear output. That will clear all of the output for all of the cells so far. You're welcome. Great. So let's talk a little bit about passing things into functions and defining that, because we have passed a lot of things, say, into print functions, and we've gotten things out of them. When I say pass, I mean when you put a variable or a thing into the parentheses. That means that's when you pass in what's called an argument, and then something comes back out. We can define something to be passed in, a parameter that can be passed into our function. And so to do that, our function definition will look like this. Def, and then we would have the name of our function, and then we would just specify that there's something that's going to be, we would specify something that's going to be passed in there. And so here's an example of what that might look like. We would have define and then greeting function. So this is just going to be a function to say hello to people. We know that we're going to pass in a username, which is going to be the person's name that it's going to greet. And all this function is going to do is it's going to print hello, and then we're going to concatenate that with the user's name. So essentially, it's just going to say hello to the person that we pass in. So this allows us to then pass variables into the functions we're defining. And so I've defined the function here. It won't run yet. I actually have to call the function here. So this is the greeting function, and I'm passing into that greeting function the string Sam. And so therefore, the greeting function will automatically print out the greeting to Sam. Now, one of the things that is a little pedantic, but I'm going to explain here, is sometimes people use the word parameter and sometimes they use the word argument. And sometimes they use them interchangeably. There's a slight difference in what these two words mean. What we call the thing up here when we're defining the function is called the parameter. And then what we actually pass in is called the argument. And so parameter is, the word parameter is only used to describe what's in the parentheses when we're doing the function definition. When we are actually using a function, when we're actually passing something into it, the thing that goes here is called the argument. So this, in this case, username is a parameter, but down here, when we put in Sam, the string Sam, that's technically an argument. And so, like I said, it's a little pedantic, but that's the distinction. And again, in practice, you'll find that people often confuse these terms, and they're often just thinking of whatever is getting passed into the function. But there's a slight difference in what those things are called. So let's try this in the next code cell. In the above example, we pass a string into our function, but we could also pass a variable. Try this in the next code cell here. Instead of just passing in the string Sam, create a variable and pass it in. So ask the user for their name, store it in a variable called username, and then call the greeting function. Now, the greeting function has already been defined, so you don't need to define the greeting function again. We already have, it's already been defined and we've already run this code. All I'm asking you to do is get the user's name, put it in a variable, and then pass in that username into the greeting function that is already defined. Again, the helpful thing about these definitions is once the function is defined, then you don't have to define it over again. You can just call it anytime. So we're going to create a variable called username, and we need input. We're going to ask the user for their name. Like that. Or alternatively, as I've said before, you could print this out separately. You could do something like, that's also an acceptable approach. I actually think it's a little bit neater because it puts the name on the next line. And then we just need to call our greeting function. It's already been created. So we have greeting function. Then all we have to do is pass in the username here. So my name is Nathan, and then it's going to say, hello, Nathan. We could also pass in not just like a string or an integer, we could pass in a list. A list is a valid data type or dictionary. And so in this case here, we have a list of names. Each name here is a string. And then I have a function. It's called greet a list, and it takes in this parameter here, names. And then it says for name in names. So we got a little bit of flow control for each name in names, print hi, and then the name in question, the current name in our flow control here. And then that's just the definition. It hasn't run yet. Here, we're actually running the function, and then we're passing in the names list, which is created up here. So then it prints out, hi, Jenny, hi, Pierre, hi, Hamed. And so we can see that the things that get passed into a function can be other types of data, not just a string or an integer or something like that. It could be a list, or it could be a dictionary, or something else. And it's also possible to specify more than one parameter. So a function could take a dozen parameters, and not all of them always have to have something passed in. But the idea is that however many things you need as inputs, you can create a whole bunch of parameters that go with a particular function that you're creating. All right, so I have a little bit of a coding challenge here. I think I'll skip over it, but I do have the answer at the bottom if you get curious about this, but it's using the example from before with the dictionaries, and it's basically creating a function that is going to print out all of the names and occupations. And we did something like this in our last class, but the idea here is to begin working with functions that take in a dictionary, not just a string or an integer or something like that. Let's talk a little bit about function return values. All functions actually return a value. It may not seem like it, but by default, they return the none value. And so you oftentimes you don't see what gets returned by a function, but something is always returned, even if that thing that's returned is none. And none is like a special word. It's like a reserved word like true or false or something like that. It doesn't just mean like 0 or something like that. It has a special meaning in Python. And so what we can do is we can return certain things from within a function rather than just returning none. And so in the example here, I have a basic fortune picker. And the fortune picker is just going to use an if-else if sandwich. Looks like it's an open face sandwich. It doesn't have an else on the bottom. But the idea here is I'm defining a fortune picker function, and it takes in a fortune number. Whatever the number is, it's going to return a particular fortune back. So if the fortune number is equal to 1, it's going to say you will have 6 children. Else, if the fortune number is equal to 2, it's going to say you will become very wise. And so we have 6 different fortunes here, and we're basically showing that that something is returned. And so here I have the value fortune, and then I'm running the fortune picker function. I'm just passing in 3 here. We'll see in a moment how we could pass in a random number rather than assigning the value each time. But since we're passing in this integer manually, we will only get back this fortune number 3. And so this is going to return this string here. And then that string will be set equal to fortune here. And then we're just printing out the value that is inside of fortune. Okay, so it's not going to be super exciting at this point because we're just picking 3 each time, although I suppose we could change the number that gets passed in here and it will return a different fortune each time. But we could also use, our some options that are out there in terms of other modules and functions that other folks have written to make our fortune teller a little bit more interesting. So essentially what we need for our fortune teller is to pick a random number between 1 and 6. And so it's almost like we need like a dice or something like that, right? And so there is a function that happens to do this. It's called random integer, and it's in the random module. And so essentially this next code cell here is adding this in. It's saying from the random module, import randint. Randint is random integer. And that is what's going to allow us to generate a random number. And so the code here in terms of randint, what gets passed into randint is essentially the bottom threshold and the top threshold for where the integer should be. So should it be between 1 and 10 or 1 and 50 or something like that? We pass in kind of the lower bound and the upper bound for that number. And so here's our fortune picker again. And then we're going to pick a random number and we're going to assign it. We're going to assign it here. So this is the random number. And here's the function randint. And it's going to pick a number between 1 and 6. And so once we have that random number, then we're going to get our fortune by passing the random number that was picked into our fortune picker. And then that will return a string. The string will go into our fortune variable here. And then it's going to print your fortune is, and then it will print the fortune. This code down here is just a little bit of fanciness to allow you to get additional fortunes. But the key thing that I want you to see here is the ability to return a particular string or return a particular value based on the function definition. So let's give this a try. So it starts off and it automatically gives me my first fortune. It says you will become very wise. So it must have picked fortune number 2. This is asking, would you like another fortune? And so I have it here essentially to, if I put in YES or capital YES, it's going to deliver another fortune. And so if I do that, it should give me a different fortune. It says sort yourself out and then find love. If I do yes again, it says do not eat the sushi. And then if I put anything except for YES, it's going to stop and say I have no more fortunes to share. But like I said, this is a little bit fancier in that it allows us to generate more fortunes. But the key thing I want you to get from the setup is, one, that you can return values from a function definition, and 2, that we can import this kind of random integer module or random randint function, and it allows us to create a random integer. And so there's a whole bunch of options out there to make your code more sophisticated by using functions that other folks have written. You don't have to understand how the randint works. You just have to know, well, I need to pass in the lower bound and the upper bound, and it's going to do the rest of the work for me in its black box. Now, if you wanted to, you could go look up and see what randint is doing and how it's generating those random numbers. It turns out it's really difficult to generate purely random numbers with computers. It's a very difficult task. And so if you were like a hacker type person, you might look up how is that random number being generated and see if you could predict it a little bit better. There's famous examples of people who have done that. They've gotten the code to say gambling machines at casinos, like a slot machine, and they figure out, oh, this is the way they're generating the random numbers, and it's not actually completely random. And if you know how it's generated, then you can exploit the slot machine. Okay, I've got another coding challenge here that works with dictionaries. I'm going to skip over that. Again, there's a solution at the end of this lesson that does this particular challenge. If you have questions, of course, email me and I'll get back to you and help you out if you're struggling with this particular challenge. I want to talk a little bit about local and global scope. I think this is a really difficult concept to explain, so I'm going to do my best. But the idea here is that the concepts of local and global scope allow us to avoid collisions on names. So I talked a little while ago about the problem of what if two people create the same, name a function the same thing, and then two people then try and call that function and it doesn't do what they expect, right? And I said the way that we get around that is by only importing certain modules or certain functions that we need and not importing all of the modules or all the functions. So the example I gave was a bank function, and there was a financial bank function, there was an airplane bank function, and then there was like a soil erosion water bank function, river bank function. And I said the way that we avoid the collision between those names is essentially by only importing it. So there might be like a module that's like, this is for soil scientists, and one that's like, well, this is for airplane physicists. And then there would be one that this is for financial analysts. And so you would import the financial analyst module or the airplane module or the erosion module, and then you wouldn't get collisions between the different functions. You can have a similar type of collision issue when you name variables. And this becomes even more significant as your program gets big. And so sometimes when you work on a very big program, it could be, could potentially be millions of lines of code, and you have some people working on one section and some people working on another section. And that makes it likely that at some point in time, somebody's going to name a variable the same thing as somebody else, right? And so these concepts of local and global scope essentially help to avoid collisions between variable names. And the idea here is that when a variable is named within a function definition, that variable is run when the function is called, and when the function closes out or finishes running, that variable is then deleted and it's kind of like vaporized, it disappears. And so the idea here is that like at any point in time when a variable would get created in that function, it only exists for the time it needs to within that function, and then after the function is closed, that variable is gone. And that way it won't collide with some other version, some other variable that is out there that has the exact same name. Okay, and so I guess this is a few things, a few ways we can look at this. So first of all, there's a kind of global scope, and that is kind of the highest level. It's outside of any function definitions. And so you can think of that kind of like the main program. And so there's like global scope where we can create global variables, and those variables will be accessible outside of any functions and also inside of any functions. But then there's also like a local scope, or kind of, it's kind of like a local community, right? It's like, well, here in this local community, we talk about these variables, but other people in other communities or other places don't know about these variables, right? This is just something that happens within this local scope of this particular function. And so in the local scope, Python can work with a global variable, say, but it can't necessarily, it can work with a global variable, I should say, and it can also work with local variables. So let's take a look at some examples, because I feel like this may make this a little bit clearer. So here I have got a variable called global string, and inside is just a string called global. And then here I'm defining a function. It's just called print strings. And it's going to print, first of all, we're in the local context, because once this function actually runs, we'll be in the local context of that particular function. And inside of that function, we're going to create a local string, which is just going to have the string local here. And then we're going to print global string, and then we're going to print local string. And so if I then run my print strings function, it should be able to, in this context, both print the global string because it's outside of the function, so it's accessible everywhere. That's a global string. No matter where you are, you can access that global string. And then when I run print local string within this particular function, it will also be able to print the local string that was defined inside of that function. Now, after that closes out, well, first of all, let's try that by itself. So we should be able to get both of these strings. So it says we are in the local context, and then it prints the global string, and then it also prints the local string, right? So we're able to do both. Now, in the code I just commented out that we're going to run after that, the function will come to a close. Print strings ends right here, and we go back to the indentation. And so that means we're in the global context again. The local variable that is here, it's called local string, has been closed. And so it is deleted. Once that function has closed and run, this local string evaporates and disappears. And so then we print out, we are now in the global context. We print out the global string, which will work fine. But when we go to print this local string, what we'll see is that we get an error. So first of all, it prints the global here, but when we go to print local string, it says name local string is not defined. And that's because the local string was defined inside of this function, but the function has now closed. So when we go to print the local string, it's no longer available. It's no longer accessible. And so it's been deleted. All right, I'm going to pause there because this is a tough concept, I think. If you haven't programmed before, if you have programmed before, you've seen this one. But if you haven't, like this is kind of confusing, this local and global. Linnea asks, why is global string still available? So the reason global string is still available is because it was defined up here. It was not defined inside of the function definition. If it had been defined inside of the function definition, then it would no longer be accessible once it closed. And so global variables are always accessible, whether we're inside of a function or not. You can always access a global variable, but local variables are only accessible when we're inside of a function where that local variable is defined. I'm going to pause and see if folks have more questions, because like I said, this is a difficult question. This is a difficult concept. And so if you find this challenging, I also find it challenging to try and explain. And if you have examples of other folks that have explained it better, yeah, share them with me because I want to get better at my teaching. Eric asked a question. If you change a global variable inside a function, does that change it everywhere? There is a way to change a global variable inside a function, and I'll show you what that is. It's with a global statement. It's generally not a great idea to do it that way, but it is possible to do that, Eric. It is possible to change a global variable inside of a function and have it change it everywhere. So maybe I'll just skip down to that since Eric asked the question. So here is an example of that global statement. If you have a string and it's called global here, and then we have a function, I'm calling it change global variable. And then there's this statement here, global string. The string here is just happens to be the name of the variable. And so if you do a statement like this, global, and then whatever the name of the variable is, in this case, it's just called string, but it could be, I don't know, it could be username or something else. Whatever the thing is that's being changed, if you change it, if you do this global statement, you are essentially saying to Python, I want you, the thing that I'm working with here is the global version. And so I want you to change the variable that is global. And so here we have a global string, and then it's saying it's giving a new value here. It's called, instead of global, it's global is changed. And then it's printing the string, and then we're printing it again outside. So when we run that, we see global is changed is printed here. And then we see even when the function closes, global is changed sticks. It's still sticky. And so it has changed not only in the local context, but also in the global context as well. Again, this can be a tricky thing to troubleshoot. So I don't normally recommend that people write their code this way to change global variables in the kind of local scope, but it is possible. And so I want to show you how that's done in case you're curious. Now, what happens, you might ask, what if there is a collision? What if you create a local variable that has the same name as a global variable? What do you think is going to happen? First, let's just guess. What would you expect to happen? If we have two variables, and one is defined locally and one is defined globally, what do you think is going to happen? That's essentially what's happening here. An error is a good guess, but it's not actually an error. Daria's got it right. It's going to prefer the local over the global. Yeah. So here's an example. I have string and I set it to global. And then I have a function here, share strings. And then here I create a new variable called string. It's got the same name. We have a string here that's a global variable. And here I have a string here that's a local variable. I'm going to print string here. And in this context, it's going to prefer, since we're in a local context, it's going to prefer the local variable. But then after it closes, I'm going to print string again. So we're going to print string here and we're going to print string here. The code is the same. It's printing string in both places, but this print string is in a global context and this print string is in a local context. So essentially the same code is going in each time, but the variable is defined differently each time. And the idea here is that in the local context, you should prefer whatever was defined in the local context. So, and that makes sense because you never kind of know what things are going to be called in a global context. And so if it's within a function, you would probably prefer that they use the variables the way that they're used locally. So that's what would happen. Just to clarify, if there is a kind of collision between those two things. I want to take the last 5 minutes or so to talk about some of the popular packages that are out there, because we've talked a little bit about writing our functions and how you could possibly create your own modules and packages and functions and share them with other folks. But I want to talk a little bit about some of the most popular things that are out there because it could be a springboard for what you want to learn next after we're done. So let's talk about some of the most popular modules out there. Some of the most popular are for processing and cleaning data. And if you've ever done a text analysis project, you know this is the bulk of the work. And so one is something called NumPy or numerical Python. And basically this is used to speed up scientific analysis. It's used with very large arrays of data. And so if you have a whole bunch of data you need to crunch and like run through analysis of some kind, then NumPy is a very popular way of doing that. It uses C++ and other kind of optimized ways to analyze and crunch the data. And so it's much faster than regular Python, say. Python is kind of like a very average all-around language. Like it's very flexible and it does everything okay, but then there are other languages that do certain things much better and faster, if that makes sense. So Python is like a very flexible language, but if you have like a whole bunch of data to crunch, using kind of regular Python might not be the most efficient way. And so NumPy will help you crunch big amounts of data more quickly. Pandas, and I have a number of lessons on pandas that are available in here. Pandas is basically for data manipulation and cleanup. I think of it kind of like super-powered Excel. It allows you to do really powerful things with tabular data. If you're interested in those pandas lessons, there's pandas 1, 2, I think I'm still working on 3, but those are available in here as well. And occasionally with Consulate, we teach classes in pandas. We have matplotlib, which basically allows us to create interactive visualizations, and Seaborn, which is an expansion on that. So this is all about visualizing data. Plotly, that allows us to create graphs, analytics, and statistics. Dash is for creating dashboards. In the text analysis world, there are a few different popular packages. These are just a few of them. Spacey allows you to do text analysis on a variety of languages. GenSim, I have a few lessons in here that do GenSim, that use GenSim to do things like topic modeling and significant terms analysis, TF-IDF. And the Natural Language Toolkit that allows you to basically do text analysis things, including tokenization. There's a few lessons in here on tokenization and tokenizers and things like that, which is basically just splitting up language into words and smaller chunks. On the artificial intelligence and machine learning front, we have scikit-learn, Keras, and TensorFlow. If you're interested in machine learning and artificial intelligence, these are the libraries I would encourage you to check out. In terms of gathering data or bringing data into Python and beginning to analyze it, requests and URL lib3, these are basically web clients that can go out and grab particular files and bring it into your environment. So if you want to download a data set or a CSV file from a link in Google Drive, you could use something like that. Beautiful Soup is a way to pull data out of HTML or XML files. It's basically something you can use to scrape websites. Scrapey is also another tool that you can use to scrape data from websites. Tweepy scrapes from Twitter. It uses the Twitter API. Praw uses the Reddit API. So if you're interested in analyzing social media data, check out Tweepy and Praw. On the textual digitization front, we have things like Tesseract, which is used for optical character recognition, something of interest to librarians. And Pillow, which is used for reading and manipulating images with Python. Oftentimes you're using Pillow and Tesseract together. Maybe you're like defining a bounding box with Pillow and then cutting out that section of text that you want to analyze, and then you're running it through Tesseract, which is actually pulling out the text and turning it into plain text. If you want to install a particular package with Python or a particular Python package in Consulate, you can use this exclamation point notation. This is not actually running Python code. This is it's a terminal command essentially, and it's using the pip installer in this case. So it's pip install and then the name of the package. If you're interested in checking out some of the packages that are out there, the Python package index is kind of like the official package index. It says there are 371,565 projects out there. So there's a ton of things that you can import and analyze things with. Here's an example of how you would install Tweepy and start analyzing with that. All right, that is all I have. One more thing before we go. I'd like to hear from folks. Go ahead and type in the chat so I have a record of it. If we run another ACRL workshop, what would you like to see? What are you interested in? Hopefully it's something I've already created, but if it isn't, it might be something that I create just for ACRL. So if there are certain things that you're like, wow, now I have the basics. I understand the basics of Python. What is the thing I really want to learn how to do? And so this is your opportunity to, now that you have kind of the basic skills and you're ready to go beyond Python basics, what should we offer next? If we're able to offer another class, let me know in the chat, or send me an email as well. I'll drop in my email here. and send me an email. Maybe you don't know right away and you have to think about it. Send me an email and we'll look at those possibilities and hopefully we can do some more programming with ACRL. This has been a lot of fun and I hope you found it useful. And I think we'll end there. And if you've got to go, then I'll see you later. Otherwise, as always, I'll hang out for 10, 15 minutes. If folks have questions, I'll try and answer questions. And yeah, we'll call it a close. Thank you so much, folks, for coming out. I'm going to take a look at this chat here.